Hello my dear students, today we will discuss about polynomials. I am Nurzaman Shaikh and I will start the chapter polynomial. Okay, so it is from class 9 polynomials chapter. The chapter is 7.1. At first we have to know what is polynomial. So what is the definition of polynomials? The polynomials are the algebraic expressions of which the indices of the variables are whole numbers. So the polynomials are the algebraic expressions of which the indices of the variables are whole numbers. So at first we have to know what is algebraic expressions. We have to know at first, and then indices of the variables. So variables and indices are two terms we have to know, and then what are whole numbers. We know about whole numbers because we have already learned about whole numbers in real numbers. Therefore it is not difficult. So at first algebraic expressions. Here 3x and minus 5x square or 4x cube minus 3x plus 1, these are the algebraic expressions. Here x are variables. These are algebraic expressions, and here x is the variable and the indices is the power of the variable. The power of the variable is called indices. It is called index in singular number, index, and the plural number is indices. Okay, indices is plural. Okay, so these are the indices. Here x to the power 1 is the power of the variable. Here 3, and here 2, and here also 1. So these are the indices. Here 1, 2, 3, and again 1. So these are whole numbers or not? These are whole numbers, because we know the whole numbers starts from 0, 1, 2, 3, 4, etc. So 0 plus natural numbers are called whole numbers. All the natural numbers along with 0 are called whole numbers. Suppose 3x plus root x, it is a polynomial or not? Because 3x plus root x means x to the power 1 by 2, and if there is any number is given here, then it is called cube root of x. That means the x to the power 1 by 3. Okay, in this way. This one and this one are not same. It is the coefficient of root x, and it is the cube root of x. It is a coefficient, but it is not a coefficient. It is the power of x, index. It is the index of this variable. Okay, it is a different thing. It means is 3x to the power half. Here x is the variable and the power, therefore the index is 1. Here index is 1 by 2. So 1 by 2 is not a whole number. 1 by 2 is not a whole number. Therefore this one is given. So this one is not a polynomial. Okay, all the powers, all the indices must be whole number. This one is also not a polynomial, this one also not a polynomial. X plus 1 by x, x plus 1 by x is a polynomial or not? Here x plus 1 by x means x to the power minus 1. So minus 1 is not a whole number because whole number starts from 0. Minus 1 is an integer, not a whole number. So this one is minus 1 is not a whole number, therefore this expression, this algebraic expression is not a polynomial, is not a polynomial. Next example, I have taken that 3x plus 3x square plus root 5. This algebraic expression is a polynomial or not? The variable is x and the power or index, and the index is 2. 2 is a whole number. This part is constant part. This expression, this algebraic expression is a polynomial. Now the term of the polynomial. Term of the polynomial. Term 3x to the 5 minus 7x square plus 3x plus 1. How many terms are there? There are 1 term, 2 term, 3 and 4. There are 4 terms in this algebraic expression. 3x, x is the variable, 3 is the coefficient, and 3 is also a constant. So 3 is the coefficient of x, and it has 1 term, therefore it is called monomial. If any algebraic expression have 2 terms like this expression, then it is called binomial. X cube plus x square plus 3. For this example, here 3 terms are there, so it is called trinomial. But remember, all these are polynomial. Degree. What is degree? Degree is the highest power of the variable in a polynomial. So here the power of the variable is 1. So this one is, so 3x is 1. That means it is a first degree polynomial. And it has x square plus 2. The power of x is 2. Therefore, if I add here 2x, no problem. But here you have to see the power of the variable. Highest power is x to the power 2. Therefore, 2 is the power. Therefore, it is a second degree polynomial. And here the power of the x is 3. Therefore, it is a third degree polynomial. It is third degree polynomial. This polynomial is called the second degree polynomial in one variable. X cube plus x square y square plus y. Here two variables, x and y. So therefore what is the degree of this polynomial? Here 3 and 2. What will be the degree of this polynomial? If in a polynomial there are two variables are multiplied together, then you have to add the powers of the variables, then you can get the degree of this polynomial. So therefore the degree of this polynomial is not 3. Here the degree of this polynomial is 2 plus 2 is equal to 4. So 4 is the degree. So it is fourth degree polynomial, or you can say degree is 4. Now find out the degree of this polynomial x cube plus a square x square plus x. Here the power is 3 and you can see the a square and x square. But remember, in this chapter a is not a variable, a is a constant. Sometimes a is a variable, but in this chapter a is constant here. So we can't count the power of the a or b or c. Okay, a, b, c are the constant. So here the degree of this polynomial is 3. Degree is 3 here, not 4. Okay, remember this one, because in this chapter you can see the 4 square x square plus y square plus ay like this, or by. So here b, a and c are not a variable, these are the constant. Question number 1. So first read the instruction. Let us write which are the polynomials in the following algebraic expressions here, and let us write the degree of each of the polynomial. So first we have to decide which are the polynomials and find out the degree of this polynomial. Okay, so let's write first one. 2x to the 6 minus 4x to the 5. 2x to the 6 minus 4x to the 5 plus 7x square plus 7x square plus 3. So which one is polynomial and what is the degree? I'll be written here. So at first look at the indices of the variable. So variable is x here and the indices are 6, 5, 2. So all these are whole numbers. So these are polynomial. The degree is x to the 6. 6 is the highest power. So 6 is the degree. Number 2, x to the minus 2 plus 2x to the minus 1 plus 4. So you can easily see that the powers of x, the powers of the variable x to the minus 2 minus okay, I'll write here x to the minus 2 plus 2x to the minus 1 plus 4. Here minus 2 and minus 1. So minus 2 and minus 1 are not whole numbers, therefore this is not a polynomial and you can find the degree of this polynomial. Okay, now let's move on to the next one. Y to the power 3 minus 3 by 4y, 3 by 4y plus root 7 plus root 7. So here the variables are y and y, therefore it is a, so 3 and 1, the powers are 3 and 1, therefore these are whole numbers. 1 and 3 are whole numbers, therefore it is a polynomial and the power, the highest power is 3. So 3 is the degree of this polynomial. So number 4, 1 by x minus x plus 2, 1 by x minus x plus 2. If you can't find the powers of the variables, then you have to simplify it. So it is a x to the minus 1 minus x plus 2, therefore minus 1 is the power. Minus 1 is not a whole number, therefore this is not a polynomial and we can't decide the degree of this polynomial. Number 5 is simple, that x to the power 51 minus 1, x to the power 51 minus 1. So 51 is a whole number, therefore it is a polynomial and the degree is 51. Question number 6, here cube root of t, cube root of t plus t by 27 plus t by 27. So you can simplify it, t to the power 1 by 3 plus t by 27. So the power is 1 by 3. 1 by 3 is not a whole number. Therefore, it is not a polynomial and degree is none. Question number 7. 7 is 15. So 15 is a polynomial or not? Yes, it is a polynomial, because these are called constant polynomials. 15, okay, 0, minus 7, all these are called 5, all these are called constant polynomials. Polynomial. Okay, so these are polynomials because you can write 15 into x to the power 0, because x to the power 0 is equal to 1. So 1 into 15 is equal to 15. So you can write with a variable, and the power of the variable is 0. 0 is a whole number, we know it. 0 is a whole number. So therefore 15 is a polynomial. Okay, and the degree of the polynomial. So what is the degree here, or what is the highest power? 0 is the highest power, therefore the degree is 0. Next one is 0. So I have written here 0. 0 is constant polynomial, but it is also called 0 polynomial. It is also called 0 polynomial. For 0, it is exceptional, because you can write 0 into x to the power 0. Okay, it is correct, because x to the power 0 means 1. 1 into 0 is equal to 0. Okay, and 0 into x to the 5, because it also gives the 0, because x to the 5 into 0, 0 into something is equal to 0, therefore it also gives the 0. Or you can express 0 is equal to x to the power 10. So all these are possible. 0 into x to the power 10. Okay, so you can express 0 is equal to 0 into x to the power 10. So all these are possible. We can't decide what is the power of the variable. It may be 10, maybe 5, or it may be 0. So it is a polynomial. It is a polynomial, but we can't decide the degree of this polynomial. So therefore the degree is undefined. Degree is undefined for 0. Question number 9. It is as simple as question number 4. It is repeated here. Y cube plus 4 is also same. Whatever 3 is the power here. So 3 is a whole number. So it is a polynomial, and the degree will be 3. Here 11. 1 by root 2 x square minus root x. Root 2x plus 2. 1 by root 2 x square, 1 by root 2 x square minus root 2x plus 2. So look at here, this part is constant part. X is a variable, and the power of the x is 2 here, and here root 2 is a constant part. It is a coefficient of x, and here the power is 1. So 1 and 2 are whole numbers, therefore it is a polynomial, and the highest power is 2, therefore 2 is the degree. Now move on to the next question. Question number 2. In the following polynomials, let us write which are first degree polynomials in one variable, which are second degree polynomials in one variable, and which are third degree polynomials in one variable. So we have to find out the degrees of the polynomials which are in one variable. So I have explained it earlier, because and you can find out easily. So 2x plus 17, here x to the power 1, and x is the only one variable here. So it is a first degree polynomial. So in this way you can find out all this degree of this polynomial. I have already explained it. Look at question number 3. Minus 3 plus 2y square plus 5xy. In this polynomial there are two variables, but we have to find out the degrees which have only one variable. So we don't need to calculate the degrees of this polynomial. So move on to the next question. Here one variable, here one variable, and one variable. Okay. So question number 3. I will go to question number 3. Let us write the coefficients of the following polynomials according to the guidelines. 5x cube minus 13x square plus 2. So here x to the cube. So the coefficient of x cube is 5. Okay, with sign. The coefficient of x cube 5. Okay. Question number 2. The coefficient of x. The coefficient of x. Here the question is x square minus x plus 2. The coefficient of x is minus 1. Here x is minus 1 because I told it that you must take it with sign. And the coefficient of x square, the coefficient of x square is 8x minus 19. 8x minus 19. The coefficient of x square term is not exist in this polynomial. Therefore the 0 into x square plus 8x minus 19 is the polynomial here. That means the coefficient of x square is 0. If any term is missing, then the coefficient must be 0. Okay, therefore the coefficient of x square is 0. And question number 4 is the coefficient of x to the power 0. The coefficient of x to the power 0 in root 11 minus 3 root 11x root 11 minus 3 root 11x. Okay, root 11x plus x square plus x square. So coefficient of x to the power 0, which is the constant. Here x to the power 1 because root 11 into x to the power 0, x to the power 0 means 1. Therefore the root 11 into x to the power 0 minus 3 root 11 x plus x square, you can write. Okay, that means the coefficient of x to the power 0 is root 11.